Welcome to part 7 in our series on assessment. This part focuses on item response theory. So we're going to go through why we need a more advanced model than the one that we presented in part 6, what that model is, and what 3 parameters define it. Starting with why we need a more advanced model. The old model had one difficulty value per assessment item and one only. This works in the context of a single classroom analysis, but not for different groups. If you have an AP class on a topic, you'd expect a higher proportion of them to get it right, for example. There was no detailed allowance for random correct guessing on multiple choice. We don't know how much of that difficulty is from people just simply guessing correctly. So we need a more general model. This is where Georg Rasch comes in. He was a professional statistician who was hired to develop this model. His model bases everything on the student's ability. That's the parameter that defines the question in a lot of cases. He recognized that, for example, a grade 6 question might be almost impossible for a kindergarten student and also insultingly easy to a grade 12. So that student ability is a big factor in the probability of them getting it right. So he came up with a model that's based on 3 parameters, although it could be simplified down to 1. And this curve describes that model. So if this is a typical question whose difficulty is right at the start of grade 6, then we can see from this graph that students in grade 3 and down would find it almost impossible. Students in grade 8 and up would find it almost insultingly easy. And students right at that grade 6 level have a probability of 0.5 of getting it right. So the probability of getting it correct is on our vertical axis, and the ability level involved is on the horizontal, where in this case the ability level is the grade level. That's not always the case. You have the freedom to pick a scale there. This is the actual equation that Rasch came up with to describe things. In this case, theta is the student ability. P is a function of theta. That's the probability that a student with ability theta answers the question correctly. We also see A, B, and C in this model. A is Rasch's version of discrimination. If you are using a single parameter model, then the default value is 1. If you are using a 2-parameter model, then you're probably using A and B rather than C. B is Rasch's difficulty. So that's our B term here. If you only have one parameter in the model, this is the parameter that gets used. And C is what Rasch called the pseudochance level. If you're in a single or 2-parameter model, this gets defaulted to 0. So let's go through those 3 variables one at a time. In the oversimplified definition, that B term, Rasch's difficulty, is the ability level of a student who has a 50% chance of answering correctly. I say it's oversimplified because this definition only works if you have a 1 or 2 parameter fit. A better definition, that will be more fully explained in part 8, is that B term is the student ability level at which we gain the maximum amount of information from that student's response to this question. The symbol for it is B. Here we have 3 curves, where the red curve has a B parameter or difficulty of 5, the blue curve is 6, and the teal curve is 7. So the same shape, just shifted horizontally according to their positions. Rasch's discrimination. This is an indicator of how quickly the student learns the skill. If you have a simple question, like the definition of a term, there'll be a very rapid climb from students getting it wrong to students getting it right. If you have a very complex idea to learn, like a lengthy mathematical procedure, well, then you get a slow, gradual climb. The symbol for it is A. We could see in this graph, all 3 of these have difficulty 6, but they've got 3 different discriminations. The red curve has a discrimination of 1/2. This is a lower difficulty, so this is the complex task. It's introduced, and then the students start to understand it, but it takes a while before they get the whole thing done correctly. So this could be, for example, multiplying a 12-digit number by a 12-digit number without a calculator. If you're doing that by hand, there's a lot of tedious calculations. It'll take a while before the student does the whole thing error-free. The blue curve is that default where the discrimination value is 1, and the teal curve is where the value is 2. That's a sharper curve, so it's more discriminatory. And that's discriminating between the top performers and the low performers. So that is a more sudden change. That's the simpler concept, like a definition, where once you introduce it, most students start getting it correct almost right away. And the third and final parameter is Rasch's pseudochance level. So this is an indicator of what the chances are that a student answers correctly purely by guessing. So it's the probability that a student with little or no ability answers correctly. In Rasch's model, there's no real upper or lower limits to these student abilities. So if the ability is -infinity, what's the probability that the student answers correctly? What does the graph approach in its limit? It's a horizontal asymptote in mathematical terms. Now, like all probabilities, it's going to be somewhere between 0 and 1, where 0 is impossible to get it correct, and 1 is they get it correct every time, like a one-option multiple choice, although I don't know why you'd assign that. A lower value is better. You don't want to have false positives. So if you have a value of 0.7, that means there's a 70% chance that an absolutely clueless student gets it right. That question is not telling you anything. It's not reliable or valid. The symbol for it is C. And if C is not 0, then you can no longer interpret that value or the parameter B, the difficulty, as the point at which a 50% chance of answering correctly is what we get at that student ability. Rather, that difficulty level B is the point where you are halfway between C probability of getting it right and 1. So we can see here 3 curves. They all have B equals 6. The red curve is like a true-false, where you have a 50% chance of answering correctly when you do not understand the material. The blue curve has a C term of 0.25. This is like a 4-question multiple choice, where the distractors are not more appealing than the right answer to the students with low ability. So this is where a student with no clue has a 25% chance of getting it correct. And then the teal curve is a C term of 0, where a student with no ability doesn't get it right. Now, even though these all have ability 6, we can see at that grade 6 level, or the ability level 6, they still have different values. The red curve has a value of 0.75. That's halfway between the 0.5 and 1. The blue curve, where C is 0.25, well, halfway between 0.25 and 1 is 0.625, or 62.5%. And the teal curve has that 0.5 difficulty level. So in our upcoming lessons, we're going to take Rasch's model and look at computerized adaptive testing. And then in part 9 of 9, we are going to look at the non-parametric version of item response theory.